Welcome to TechPrain YouTube channel. In today's video, we are setting out to navigate the fascinating world of geospatial mapping using Python and MongoDB. Let's construct a web application that visualizes geospatial data seamlessly. Geospatial mapping is the art of illustrating geographical data visually, allowing us to uncover patterns and connections across various locations. For these endeavors, we will employ Python as our backend and leverage MongoDB as our database to efficiently store and query geospatial data. We will configure a MongoDB and create a collection filled with geospatial data. Remember to establish a 2D sphere index for optimal querying performance. Next, we will assemble a Flask web application. Flask simplifies the creation of routes that will handle our geospatial queries from MongoDB. Finally, we will integrate Leaflet.js to display our data on an interactive map. This library empowers us to create dynamic maps featuring markers based on our geospatial data. By the end of this video, you will have a robust understanding of how to visualize geospatial data using Python and MongoDB. What is GeoJSON? GeoJSON is a format for encoding various geographic data structures. It allows us to store information about locations using points, lines, and shapes. This data can be represented as XY coordinates or latitude and longitude. There are two case types of geospatial data. Number one here is Cartesian coordinates for smaller distances, and we have the second, which is 2D spheres for larger distances, enabling accurate representation on a globe. We also have some use cases. MongoDB's geospatial capabilities have numerous applications. We can build location-based services, create interactive maps and visualizations, perform proximity searches, and enable real-time tracking of assets. By leveraging geospatial data in MongoDB, we can build powerful applications. MongoDB supports two types of geospatial indexes, which are 2D spheres and 2D. These indexes efficiently query documents based on geographical location, whether you're working with spherical data like latitude and longitude or flat plane data for smaller distances. Benefits of using geospatial data. Geospatial data has a variety of real-world applications like mapping services in Google Maps or Uber, proximity searches to find nearby services, and routing to calculate the shortest paths between locations. MongoDB excels at handling this data efficiently, making it highly scalable for large data sets. And we also have some use cases of geospatial data. Some common use cases include urban planning, environmental monitoring, business intelligence, and disaster management. Geospatial data provides essential insights for decision making across multiple industries. Geospatial data can take many forms, from latitude and longitude coordinates to specific locations of restaurants, landmarks, and cities. It can also represent routes like hiking trails or even countries' borders through satellite imagery. Here's an example of data for the status of Liberty and Eiffel Tower stored in MongoDB. Let me show an example on how to show an existing geospatial data, which we have already inserted to our MongoDB database locally. So to check for our existing data, you can run the following command. We have some data here in our database. So this is basically how to query your database. Now let's talk about some types of geospatial indexes. MongoDB offers two types of geospatial indexes. We have 2D sphere and 2D. The 2D sphere index is used for spherical geometry, perfect for working with the earth curvature like latitude and longitude. On the other hand, we have the 2D index, which is used for flat, that is Cartesian geometry, ideal for flat coordinate system and legacy applications. To create these indexes in MongoDB for 2D sphere, you can run the following command in your terminal to create this index. Like when you open your terminal, you're already using the Geo database. Now, let us create a 2D sphere index. you can see we've successfully created an index. Use the 2D sphere index when working with spherical data, such as global coordinates, while the 2D index works best for flat, Euclidean data where you don't need spherical accuracy. MongoDB uses the JSON format to store geographic data, representing features like points, lines, and polygons. With GeoJSON, MongoDB allows powerful queries such as the GeoWithin, Near, and GeoIntersect, which can be used for location-based services, proximity searches, and more. As we did earlier, we created a 2D sphere index on the location field in MongoDB. This will enable us to run geospatial queries. For example, queries like Near, GeoWithin, and GeoIntersect allow us to retrieve data based on location proximity or geographical boundaries. Now that we have set up the index, we'll explain the different queries you can perform. MongoDB provides 3 key geospatial queries. The first of it is Near. The Near query finds document closest to a point. We also have GeoWithin query, which finds document within a defined boundary. GeoIntersect. This query finds documents that intersect with a specified geometry. Here's a code sample of how to query for a nearby location. What are the benefits of using geospatial indexing in MongoDB? Using geospatial indexing in MongoDB provides efficient querying for proximity searches, supports complex geospatial queries using the GeoJSON format, and is scalable for large data sets. In this project, we are building the geospatial mapping application using Flask for the backend, MongoDB for data storage, and Leaflet.js for interactive map visualization. The map allows users to view geographical data and perform proximity searches and routing. We are going to use the following two. The first two here is Flask. Flask is a Python web framework for building APIs. We're going to make use of PyMongo, which is a client for MongoDB to interact with the database. We are also going to make use of a tool called Flask Calls. With this tool is used for handling cross-origin resource sharing. We're also going to make use of the Leaflet.js library. This is a JavaScript library for interactive maps. And likewise, we're going to make use of jQuery for handling HTTP requests and DOM manipulation. To get started, create a Python virtual environment and install the required libraries. Before creating the virtual environment, make sure you create a project directory where you save all files. Now to do that, we create a directory named Geospatial. Now let us proceed by creating our virtual environment. Now we successfully created our virtual environment. Let us activate our virtual environment. Now we've activated our virtual environment. Let us install the necessary libraries. Now we successfully installed all the necessary libraries. Let us open our Visual Studio Code. Here is a virtual environment folder. Let's start by initializing our Flask application and setting up a connection to MongoDB. We are also enabling calls for cross-origin requests. This code snippet initializes the Flask app, connects to MongoDB, and targets a specific collection where our geospatial data is stored. We're also going to create an endpoint to retrieve nearby places based on user's current location. We're going to make use of the geospatial query to find places near the given coordinate. Now let's proceed to our Visual Studio Code. We'll name the file app.py. We've successfully initialize our Flask application and set up the connection to MongoDB. We also enable calls for cross-origin requests. Next, we're going to create an endpoint to retrieve in nearby places based on user's current location. Now we created an endpoint to retrieve nearby places based on user's current location. Next, we're going to make use of the Geospatial query to find places near the given coordinates. Now we've successfully created an endpoint to retrieve nearby places based on the user's current location using latitude and longitude parameters. And we've also implemented the Geospatial query to find places near the given coordinate. This endpoint grabs the user's coordinates and performs a Geospatial query to find places within a 5-kilometer radius. You might have this question in mind that why do we use Flask in this project? We are using Flask for this project because Flask is lightweight and flexible. It allows us to build small-scale APIs quickly. It is perfect for creating RESTful endpoints and can easily be extended with additional libraries like Flask calls. Now let's run the Flask server. We've saved the code as app.py. Then let's start the Flask server by running the following command as shown on the screen. Now our Flask app is running successfully. Now that we successfully create our API, let's start by setting up the basic HTML structure for our map. We include the Leaflet.js and jQuery libraries, which will help us render the map and fetch data from our API. Now let us create an index.html file. This sets up the map display with a height of 600 pixels and links to Leaflet and jQuery. Leaflet.js is a lightweight JavaScript library designed for interactive maps and geospatial data visualization. It is user-friendly, interactive, and easily integrates with other libraries. Now let us fetch data from the Flask API and display it as markers on the map. Now let's go to our Visual Studio Code. So we initialize the map. We add OpenStreetMap tile layers. Then we check if the browser supports geolocation. Then we get users latitude and longitude. We fetch geospatial data from Flask server. Now let's run a local HTTP server to test the application. In your terminal, navigate to the directory containing your index.html file and run the following command depending on your Python version. Here I'm using Python 3. For those using Python 2, you can run the following command on your terminal. But I have Python version 3 installed on my machine, so I'm going to make use of the following command. You can see it's serving HTTP on port 8000. Let's go to our browser to view our map. View the map at HTTP and view your browser. You can see our map on the browser. Now click on allow this time to know your location. So you open your browser and go to this spot here. Copy this URL and paste in on your browser. As shown earlier, you'll see this map displayed on your browser. And that is it. We built a fully functional geospatial mapping application with MongoDB's geospatial capabilities, Leaflet.js and Flask. You can efficiently query location-based data and visualize it on an interactive map. Thanks for watching.